is Bharadwaj Academy, and let's start the first topic for today. This is chemicals from salt. So we are going to discuss chemicals from salt. And the first topic for from this topic, the subtopic for this topic is the sodium hydroxide. This is sodium hydroxide. Okay, so sodium hydroxide, common name is caustic soda. The common name for that chemical is caustic soda. You must have heard that word from when you go to the market. You purchase that from the shopkeeper that I want caustic soda, so he will give you that product that is called sodium hydroxide. The formula for that chemical is NaOH. Fine. So this is the formula. This is the chemical formula, or you can say the formula for that product is NaOH. The common name is caustic soda. So, and also you can see that this is made of the base. So basically it is used in the preparation of the soap. Okay. So now we'll discuss about the how we produce that, like the production of NaOH. Okay, so we produce that with the help of electrolysis of brine. So now there will be a question in your mind that what is brine? This is like a new word introduced for you, that brine. What is brine? So brine is the concentrated aqueous solution of NaCl. That is called brine. Okay. So when we electrolysis, I'm sorry for that, the electrolysis of NaCl will give you the caustic soda. That means NaOH. Let's see how we'll get it. Just a moment, let me rub it. Okay, so quickly we will rub it. Just a moment. Okay, so now we'll do the formula for that. Okay, so this is the NaCl, the aqueous one, plus water. Okay, liquid. Now we are doing the electrolysis. That means we are passing the electricity. So what will happen? We'll get the NaOH, which is basically aqueous, plus also we get H2, plus we get Cl2. So these are the major product we obtained from that equation. The brine plus H2O, that means we are doing the electrolysis. We are passing the current in the solution. Then what will happen? We'll get NaOH, H2 and Cl2. Okay. I'm sure so far everything is good to go. You can understand each and every point. Okay. So this was the electrolysis. We obtained NaOH, H2 and Cl2. This is also known as chlor-alkali process. So why it is known so? Because chlor means chlorine and alkali means base. So because we are producing this with the help of chlorine and the base, so that is also known as the chlor-alkali process. Okay, so now we obtain three major products. One is the NaOH, one is the Cl2 and one is the H2. And all these products have its own use. Like we can use that in the formation of soap, formation of soap or used in the chemical industry, because we can produce a lot of product from that. Okay. Cl2 is the bleaching agent. Cl2 is the bleaching agent, so it can be used to produce bleaching powder, and it is used to sterilize the water. That means we can use that to fix the water, like to get the clear water. And H2, it is the fuel for rocket, and it is also used in the hydrogenation of oil. Okay, so this was about the chemical from salts for the first point which we have discussed. Now we have like 4 to 5 more points. So quickly just revise that what we have done so far from the beginning. We have studied the NaOH. What is NaOH? The chemical name is sodium hydroxide. The common name is caustic soda. The process of method of preparation is how we obtain. We obtain with the brine and electrolysis. We get NaOH, H2 plus Cl2, also known as the chloralkali process, because chlorine plus a base. Now because we have obtained 3 major products, NaOH, H2 and Cl2, so we can categorize them with their uses. Okay, what is the use of NaOH? So formation of soap and chemical industry. Bleaching is a bleaching agent, sterilize the water, and production of salt like HCl, NaOH, we can obtain this with this. And H2 is also used to obtain the salt and also fuel for the rocket combustion. You must have heard from your science teacher that hydrogen is the most significant, most useful product, most useful fuel to send the rocket to the orbits. Fine. And hydrogenation. So this was about the first topic. Now we are moving for the next topic. Okay, just a moment. Let's quickly move to the next topic. Okay, so let's start the next topic. Next topic is the washing soda. So as the name suggests, this is washing soda. So formula for washing soda is, what will be the formula? Formula will be Na2CO3 into 10H2O. Okay, so you can see that it consists of 2 parts. One is Na2CO3, one is the crystals of water. Crystals of water, also known as water of crystallization, and sodium carbonate. Okay, so its name is sodium carbonate decahydrate. This is sodium carbonate decahydrate. That means there are 10 molecules of the water, 10 crystals of the water, and sodium carbonate. And if you remove that 10 crystals from that, this is called sodium carbonate only. Sodium carbonate, also known as soda ash, also known as the soda ash. ठीक है, यानी कि इसको हम बोलते हैं सोडियम कार्बोनेट डेकाहाइड्रेट प्लस सोडियम कार्बोनेट. ठीक है, अब आता है इसका प्रोडक्शन. अब हम इसकी बात करेंगे कि हम इसको बनाएंगे कैसे. ठीक है, क्विकली विल डू दी. If you want to write that, you can write it, and then we will move forward. Okay, so now let's start the method of preparation. How we will produce that. So this we are going to produce that in the 3 steps. So now we are going to discuss the production. So production of the salt, which is called washing soda. Okay, so there are 3 steps. The first step is with what will be the agent, what will be the reactant, like sodium chloride, ammonia, water, and plus CO2. So we will have with the help of NH3, NaCl, CO2 and H2, and we combine all these 3 things. So what we obtain, like we have all these 4 things: NaCl plus ammonia plus CO2 plus H2. So what we are going to obtain, we will obtain a salt and plus sodium hydrogen carbonate, or also known as sodium bicarbonate. So this will be NaHCO3 plus NH4Cl. So we have obtained this first, this is the first step to obtain washing soda. Okay, also known as sodium hydrogen carbonate. Let's write the name: sodium hydrogen carbonate. This is called ammonium chloride. Ammonium chloride. Okay, so this is the first step. So what will be the next step? Now we will decompose that. Now we will decompose this second part. So we can see decomposition of NaHCO3. Simply we will heat it, strongly heat it. So what will obtain? Like 2 NaHCO3 heat, like we are going to heat that, so it will convert into Na2CO3. Okay, and now what else we obtain? We will obtain CO2 plus H2. So this will be the second step. Now decomposition of sodium hydrocarbon. Let's quickly go start from the first point. With the help of NaCl, ammonia, CO2 and H2, we'll get NaCO3 plus ammonium chloride. Now we decompose that product because we need to obtain what we need to obtain. We need to obtain the Na2CO3. We didn't write the formula, so Na2CO3 into 10H2O, 10 crystals of the water. That's why it's known as the. We must have write in the previous point. Okay, so now the third step will be, let's write the third step here. We just need to add the 10 crystals of the water. So the third step will be, so simple one. This is also known as the soda ash. This is known as the soda ash. So now we have the Na2CO3 plus 10H2. Simple combination reaction will take place, and that will become Na2CO3 into 10H2. So this is our washing soda. We have obtained this that product in these 3 steps, and I'm sure you must have understood that. If you have any doubt, so most welcome in the comment. Okay, thank you so much. Now, okay, so far, thank you so much for the so far. Now let's move to the use of this product, because since its name is washing soda, so all it is uses so cleansing agent in soap. This help in the cleaning, or it help in the removing the permanent hardness of water. Also useful to remove the permanent hardness of the water. You can write a few more points in that, but so far, like for our topic, that's enough. You can go through with your science book as well. If you have any doubt, most welcome. Okay, so far this is enough. Let's move to the next topic. Just a moment, let me start the third one. Okay, so the next topic is baking powder, or baking powder we'll discuss later. First we talk about the baking soda. Okay, so when we talk about the common name, it's already, the common name is baking soda itself, and its chemical name is sodium hydrogen carbonate. Okay, and its formula, when we talk about the formula, so formula is NaHCO3, sodium bicarbonate. Okay, so common name is like baking soda, and chemical name is sodium hydrogen carbonate, and formula is NaHCO3. Okay, when we talk about the production, how we will produce it, so we will produce is with the help of few agents, like we have NaCl, we have ammonia, and we have CO2, and we have H2O. So with these agents, we can produce the our product which we are going to produce, sodium hydrogen carbonate. So this is NaCl plus NH3 plus CO2 plus water. So what we will obtain? We will obtain NaHCO3 plus NH4 CO2. This is byproduct. We don't need that. This is our main product. This is called baking soda. Fine. This is about the method of preparation of the baking soda. Let's talk about its property and uses. Okay. When we talk about property, so property, we can say it is a white crystal. We can obtain it in the form of white crystals, and it is mild corrosive. That means it's not so much of strong base. Mild corrosive base. It's springly soluble in water. It's not soluble in water, but springly soluble in water. So this is about the main property of this base. And also let's write the heat, action of heat. If you heat it, then what will happen? NaHCO3 is strongly heated. So what will happen? Na2CO3 plus CO2 plus H2O. That evolution of CO2 has its own significance in this point, in this part. Okay. Now let's talk about the uses. I believe that property has been clear for you. It is a white crystal which you obtain in the reaction. It's mild corrosive base, springly soluble in water. An action of heat. If you strongly heat that, it will convert it into the sodium carbonate and water and CO2 and water. Fine. Let's quickly move to the uses of that. I'm sure everything is fine. Next is the uses of this baking soda. So first is this is used as an antacid. Since it's a base, so it can use as an antacid. That means to remove the acidity. What does it mean? Removing acidity. Okay, to removing the acidity, we use the baking soda. And the second point is, it can be, what can be the second point for the it can be used in baking powder. So baking powder is also obtained from the baking soda. And how will obtain baking soda? Soda plus any edible acid like tartric acid. Citric acid. You will use any of the acid. So what is baking powder? Baking powder is the baking soda plus any edible acid is called the baking powder. So it can be tartric acid, it can be citric acid, it can be any edible acid. Fine. So this is about the use. And the third point can be, it can be used in the fire extinguisher. Since it's produced CO2 gas, so CO2 gas inhibit the oxygen. Like so it can be used in the fire extinguisher. So you must have seen the fire extinguisher. When we remove that, it releases that sodium bicarbonate which produce CO2, ultimately stop the fire. So these are the use of the baking soda. Fine. So I'm sure this topic is very clear to you. When we talk about the reaction, so reaction is the consists of four major products like NaCl, H2O, CO2 and ammonia. With that we'll get the NaCO3. When we talk about the its property, it's like white crystals, it's corrosive, mild corrosive. And when we talk about use, it is used as an antacid. So there can be a question in your examination which product is used as an antacid. So we can write the baking soda can be used as an antacid. So whenever you feel acidity, you can have the baking soda which is available at your home. Next is the baking powder. You can make the baking powder with the help of baking soda plus tartaric acid, and it can also use in the fire extinguisher. Okay, let's quickly move to the next topic. If you have any doubt, most welcome in the comment. Fine. Just dear students, our next topic is bleaching powder. What we are going to discuss is bleaching powder. So its formula is CaOCl2. Its name is, chemical name is calcium oxychloride. Okay, so bleaching powder, the formula is CaOCl2 and the name is chemical name is calcium oxychloride, and it's also known as the, what its name is, chloride of lime. Sometimes you can see in your examination with a different name. You find the preparation, method of preparation of chloride of the lime. So that means you need to find the method of preparation of the bleaching powder. Fine. Okay, so let's quickly talk about its production, how we can produce that. So production of this bleaching agent CaOCl2 is done with the help of CaOH, like calcium hydroxide. Okay, and plus what we can obtain, we can take the chlorine gas. With the help of chlorine gas we will obtain CaOCl2, and plus what we can obtain, we will obtain the water. So calcium hydroxide plus chlorine is the calcium oxychloride plus water. Fine. This is about the production of the CaOCl2, that means the calcium. When we talk about the properties, so we can see that the bleaching, as the name suggests, it is used in the bleaching agent. Okay, so it's a white powder. The first point we can write it's a white powder, and the second point is the, what can be the second point, it is soluble in cold water. It is soluble in cold water. And third point we can write that it is, when we mix this product with the a hydrochloric acid, so, or sulfuric acid rather we can say, and CaOCl2 plus H2SO4. So with the sulfuric acid, what we will obtain? We will obtain a salt which is CaSO4. Okay, and we obtain Cl2 and water. Okay, so this is the real bleaching agent. When we talk about the properties, so why it is used as a bleaching agent? Because of this chlorine. This chlorine acts as a clean bleaching agent in this product. Fine. I'm sure there is no issue, there is no problem so far, but still you have any issue, so please let me know in the comment section. Okay, now when we talk about the use of this product, because this is a bleaching, we are talking about the bleaching. So bleaching is the, where we can use it, in the bleaching agent in the many chemical industry. Like for the first point, it is when we talk about uses, so act as a bleaching agent in cotton industry, yeah, or cotton industry, or rather you can use a very appropriate word which is called textile industry, used in the disinfecting the water. So used to disinfect the water. It can also use in the it has many uses, so let's write the other uses. It can also use in the making many chemicals help in the chemical industry. You can write help in the chemical industry. It makes wools unshrinkable. So it will help in the making the wools unshrinkable. So these are the uses. Bleaching agent in the cotton industry, or rather say textile industry. Disinfecting the water, many chemicals formation, and it makes the wool unshrinkable. I'm sure this point is very much clear to you, but still you have any doubt, so most welcome in the comment section. Let's quickly move to the last topic for this salt part, just a moment, which is called POP. So we are going to start that POP, okay? Of Paris, okay? When we talk about the formula, for this formula is CaSO4 into half H2O. Okay, its chemical name is the calcium sulfate, and this is called hemihydrate. Okay, its name is calcium sulfate hemihydrate. Fine. So hemi means half. We can say for that half we use the hemihydrate. Fine. Now let's talk about the method of preparation. How we'll use that? How we'll obtain that? We obtain the production. We produce this with the help of the gypsum. So gypsum is CaSO4 into 2H2. When we strongly heat that, almost like a high temperature, like 350 and all that, so 373 degree Kelvin. So what will happen? It will decompose into two products, CaSO4 into half H2O plus 1.5 crystals of water. Okay, so this is about the production of the plaster of Paris. When we strongly heat that gypsum, this is gypsum, we will obtain calcium sulfate hemihydrate plus water. Fine. Now when we this is about the production of the POP. Fine. Also known as the, in short we can say that POP, only POP. Fine. Now when we talk about the this is about the production of calcium sulfate. When we heat that, we got CaSO4 into half H2O plus 1.5 H2O. Now we'll talk about the uses. Okay, quickly move for the uses. So when we talk about the use, or before use, let's talk about the properties. Properties of POP. So we know that it's a white powder. Okay, it's a white powder, and the most important property of that substance is it convert into hard mass in moisture. When it get moisture, it will convert into the hard mass. Okay, this is about the property. Let's talk about its uses. Okay, and you can also write why it is so. Actually, it's not needed, but we can write that CaSO4 into half H2O, and when it get moisture, it will convert into CaSO4 into 2H2O. Again, gypsum, which is a hard substance. So this is the property why it converted into a hard mass, which is we'll talk about this property, why it happened, why is the use of that. Okay, let's rewrite the uses. So now we'll talk about the uses of POP. So first of all, it is used in the toy industry. Or you can say it is used, you must have seen many advertisement in your TV that use the POP. So POP can be help in decoration. Fine. And it is helpful in the fractured bone. In the doctor used that. Doctors used to fix the fractured bone. Fine. I'm sure if you are not able to see that, but at least you can hear that. So this point is the doctors used to fix the fractured bones. Fine. And in the decoration, you must have seen the news in the TV that we use the POP to make the roof more attractive and more designing. In the toy industry, like we can use that in the like to fix the toy, the broken toys. We can, with the help of this, we can settle them. We can fix them. Fine. So this was about the use of POP. I'm sure we have covered all the salt, and if you have any kind of doubt, if you need more explanation in any specific topic, just let me know in the comment section. We'll talk about that. Okay. And in the last, let me quickly give you a brief overview of the last point, which is about the water of crystallization. Mainly salt octane, just like we did the Na2CO3 into 10H2. This 10H2 is called the water of crystallization. Water of crystallization. That means that salt have its specific color because of this salt. If you heat that water will disappear from that, and that salt will be a colorless substance. Okay, so this part is called water of crystallization. That means all the salt is when the crystal of all the salt are consist of the water crystal. That's why they have their own color. So this was the brief part of that last topic. You can simply just go through with this. You can read that. Simply it is mentioned that the water of the crystals like copper sulfate, CuSO4, into 5H2 or 10H2O and all that. All the things is called the water of crystallization. Just remove that. What you obtain, you will obtain only simple salt, which might be the colorless, or which will have a different color from the existing salt with the water. Okay. So again, thank you so much for watching this video, this entire video. If you have any kind of doubt, most welcome in the comment section. Okay. Once again, if you like the video, please comment, like, subscribe and share. Okay. Thank you so much. Have a nice day.